Hello, also from my side. My name is Marcel Sponer. I'm from Vodafone, and I'm planning to talk about our USP journey at Vodafone so far. Before I go to the actual content, or before I go to the content that I've prepared, I quickly wanted to introduce the topics that I would like to cover today. So first, like Volker did, a very brief introduction about the company I'm working for and about myself. And then I'll be talking about the service strategy that we're having at Vodafone. And this part is actually some kind of a repetition to stuff that we have already heard the last 1.5 days during this conference. But as James also mentioned yesterday, quite often repetition is good. Yeah, so I'll be doing some repetition here as well. The main part of the presentation is actually about some real world scenarios and use cases that we've implemented based on USP at Vodafone. And then at the end, I'll just briefly take some kind of an interim conclusion, and we'll talk a bit about what we are planning to do next with USP. And because I've brought a lot of content, I should better hurry up to leave a bit of space at the end for Q&A. So quickly about Vodafone. You all know we are all from the same industry, so we are a big operator as well. We have many millions of subscribers in mobile, in fixed broadband networks all around the globe. We offer all different kinds of network access technologies. And important for the content that I've brought is to take into consideration that we as a company, we actually grew a lot by acquisition. So we have a large variety of different CPEs, different models, vendors, network and IT systems in our stack. And that's coming with some challenges. Quickly about myself, because this is the first time I'm talking in front of the BBF. My name is Marcel, as I've already mentioned. I'm normally not talking, but more doing. So I'm an engineer and an architect, and I work on different products at Vodafone. By education, I'm a computer scientist. I'm now since more than 10 years working for Vodafone on different products. Currently, our department is called Home Technology and Products. So we are building products and services for the consumer segment. The department is part of Vodafone Group. That's also important to know, because Vodafone see it like there's this horizontal on top of the local market companies, and Vodafone Group is the horizontal that sits on top of it. And I belong to this area, and we are actually building products that we are then trying to roll out into the different local markets that we call the OpCos, the operating companies. Yeah, so my day-to-day job, I do a lot of software engineering and architecture. And the work focus that I have is that since day one, I'm influencing and driving a bit the evolution of a network security product that we have at Vodafone. So that's why, for example, I know Tom, who gave a talk earlier. It's called SecureNet, so it's not so relevant for the talk today, but I just wanted to mention it. And the other half of my time I'm spending on now the Vodafone internal USP implementation, which actually brought me here, which actually came to life about 2.5 years ago. So since 2.5 years, I'm actually doing this now as well. So what is the service strategy that we are implementing and executing at Vodafone? So here now comes the part where I said it's a bit of a repetition to what we heard yesterday. Traditionally, CPEs were seen as these network boxes which provide connectivity, and we are now in some sort of a transition or transformation phase where we are trying to transform these connectivity network boxes into what our business calls the so-called service hubs. So what does this include? So for us, this includes that we want to use these devices for providing value-added services. To be able to provide value-added services, we need to know what customers actually need and what they want. So we need these devices to be big data ready, so that they help us to collect information and that we generate customer insights based on the data that we are collecting. And we want to reduce the technical barrier that these devices normally have, so that customers have a good experience when interacting with our platform and our services. So that's this transition phase in which we are currently into and that we are working towards. And this is a slide which tries to summarize the main building blocks that we've identified for ourselves that we need to be able to deliver this. Yeah? So USP, you can see that highlighted here, is the standardized protocol that we've selected for it. And in our implementation, we have chosen USP over MQTT for this. Then next to USP, we need the ability to remotely control services that are then actually deployed on these CPEs. And like I mentioned, 2.5 years ago, someone brave in Vodafone decided to not acquire this or to not buy this, but we decided to build this in-house. So we have in-house development teams who are developing and delivering this. Next, something that we also heard in previous talks is containerization. So that's key for us to decouple the lifecycle of service agents, which we are deploying on these boxes, from the underlying operating system, to be more agile, to be more flexible, and to have the ability to release new features on a higher pace that you normally could when integrating services directly in the CPE firmware. The next building block for us, like I mentioned already, we want to be able to make data-driven decisions. So everything should be big data ready. We need the ability to extract data from the CPE and to ingest the data into an analytics platform so that we really know what customers need and what they want. And like I mentioned, due to this fragmented ecosystem in which we're operating in, harmonization is key for us. So we are actually trying to harmonize and to define common requirements for our CPEs across different countries. And we are also trying to harmonize and consolidate the DR181 data model that we are using inside the device. All of this sits on top, obviously, on the CPE foundation. In the past, we did tactical launches based on proprietary platforms, but it was already also mentioned here that we are investing a lot into RDK. So we also have in-house development teams currently building our own RDK software stack that we are then deploying on devices. So that once we've reached this, we are then in a position that we really control end-to-end the software that runs on the device and in our backend, and can then really start delivering in-house developed software more or less from an end-to-end perspective. So that's the goal that we're working towards. Why does USP help us with this? So it's a standard, the entire industry is opted into it, and so are we. One key enabler for us, where we are sitting inside the organization, that is really helping us a lot, is this multi-controller architecture that we also heard quite a lot the last 1.5 days about, because this allows us to reduce dependencies to other parts within the company and to define a clearer separation of concerns. Yeah? So we don't need to develop and deploy a big monolithic controller that does everything, but we can really more do smaller sized controllers, more according to microservice style software development principles that define controllers to a very specific or for a very specific purpose, so that they only do what they are meant to be doing. What is important for us as well is the coexistence capability of TR69 and USP. Again, you need to remember we are an organization that sits on group. We have a lot of legacy in the local markets. ACS is normally something that the local markets are doing, and local markets have a long history in doing device management, they're doing network configuration and stuff like this. We don't want to change this. So what we are doing is on top of this, and USP is actually helping us with this, because we can just put our USP implementation on top of what is already existing and can then do more service-oriented stuff. We talked about efficiency already, so I maybe make that brief. So we do USP over MQTT, which is quite efficient, and a flexible PubSub protocol that we are using. The protobuf encoding is helping us to reduce the message size, and the search expressions are allowing us to make much more finer grained queries and to only extract the data from the CP that we actually need. The last part, we heard about WebPA. So we are also, like I said, actively contributing to RDK, and we are trying to bring USP also a bit more into RDK. So I guess that's our common interest, and we have people actively contributing to that. Good. So now to the main part, where I brought some real-world use cases that I wanted to talk you through. Before we go into this, I just wanted to put this in a bit of a more context. Yeah? So this is the helicopter high-level architecture overview on our platform. So what you can see here is that we start at the bottom. There's this big blue box, which is called the CPE, where you can see very nicely this coexistence part that I mentioned already. You have the TR69 or the SNMP agent, which is integrated with the local market ACS or whatever local device management system is used in the OPCO. You can see that we are then on top of this in peaceful coexistence, putting our USP agent on the device. The partners that we are working with here are normally taking the Broadband Forum open source reference implementation for this, and they are then integrating this into their firmware. The data model 181 is keeping this all together. In the center, you can see the service container runtime environment that we are using to isolate the service agents from the underlying operating system. You can then see on top of the CPE, there's the MQTT broker that we are using. This is actually something which for efficiency reasons and for the reasons that we can really more focus on building it, that we are using this as a cloudified, fully managed service from a partner that we are working with, so that we can really focus on building stuff over MQTT and not have to deal so much about with the necessary infrastructure part of it. You can then see that the USP agents are communicating with our backend, and in our backend you can see that we have a set of different USP controllers. Yeah? So this is addressing this multi-controller architecture paradigm that comes with USP. You can also see that the CPE platform consists of other things than USP controllers. This is needed, for example, for the necessary integration with the local market OSS and BSS systems. Next to the USP controllers, you can also see that we have a mobile application that we are providing on native platforms for Android and iOS. This is addressing the need for these customer-friendly user experiences that we want to provide. Interesting to notice that we've decided to also put a USP controller directly in the mobile application, which allows us then, once a specific pairing and onboarding procedure, which I'll talk about a bit later, has happened, that we can very efficiently directly over MQTT communicate with the device. You do also see that left of the USP agent, we have added what we call a telemetry backend, which then allows us to collect and extract the data from the CP and put this in our global big data / analytics platform. So this is the super high level architecture overview that we've implemented. And now I actually wanted to talk you through some more concrete use cases so that it gets a bit more tangible what we are doing. And I tried to put the different scenarios that we've implemented into some kind of a chronological order. Yeah? So the first question that we asked ourselves is obviously, how can we, when a device connects to the network, how can we reliably onboard this device into our platform? And how can we do this with as minimal and as little dependency to other third-party systems that might exist within the company? And this is what our solution more or less looks like. So this, first of all, gave birth to the first USP controller that we've implemented, which we call the USP Bootstrap controller. So this is a USP controller which has the sole purpose of onboarding devices to our platform and to then provision what we call functional USP controllers back onto the device. And so this is the main purpose that it solves, and the way how this works is actually defined in the specification. So the CPE, when it connects for the first time to the network, comes with a very minimal set of configuration that allows it to communicate, to establish the MQTT connection, and then to send the USP onboard notify request to our to the Bootstrap controller. The controller then has some mechanisms to identify what type of device it is, what's the local market that this device belongs to, and other criteria that it checks to then be able to identify what is the necessary functional USP controllers that have to be actually provisioned back onto the device. The provisioning procedure is also more or less defined in the standard. So we're using USP add operations to add additional USP controllers to the device. We are then initiating the send onboard request operate command, which will then result into the agent making a request, some kind of a hello world message that then goes to the newly onboarded functional USP controller. And the functional USP controller then takes over and does the provisioning that this functional USP controller needs and requires. And this then directly leads us into the second USP controller that we've implemented that we use for telemetry purposes, and that's why it's called the telemetry USP controller. So if we just play this through a bit further, so the Bootstrap controller has now onboarded the telemetry controller. So the USP agent comes to the telemetry controller and says, hello, I'm here, please configure me. What the telemetry controller is then doing, something similar to what the Bootstrap controller has already done. It checks what's the device type, what's the firmware version, what's the available data model parameters, and so on. And we are then actually doing two different things to be able to extract data, telemetry information from the device. So we are also, similar to what Deutsche Telekom and Volker is doing, we are using bulk data profiles that we are then provisioning back onto the device. We are selecting a set of data model parameters, and we are defining a frequency that we are asking the CPE to report these data model parameters into an HTTP endpoint that we are running in another serverless cloudified deployment. We are using different frequencies for this for cost efficiency reasons. Yeah, so some information is actually reported on hourly basis, others is more daily, and we also use weekly exports for data models that do not that frequently change. So from there, like I said, from this HTTP endpoint, we are then slightly transforming the information, and we are putting the information into our central analytics platform. The other half of the story is that there is some information which actually requires either a more real-time notification type of information. Yeah, so you either need the data quicker, so an hourly report is not enough, or you need some information that is hard to extract based on schedules, like, for example, the book event. So that is information that normally is better to be consumed by an analytics platform if you stream them and you have more of an event-driven ingestion approach. Yeah? And that's what we are using on the left-hand side of the illustration, where you can see that we are using USP subscriptions for this. The mechanism works similar. So once the USP controller, the telemetry controller is onboarded, it knows for which data model parameters it should set a subscription for. And what this then allows us to do, it tells the USP agent whenever there is a new object created, whenever there is a value changed, an event is fired, a notify message then goes from the device into our backend, and from our backend, then we are again slightly transforming the information, and we are ingesting it into our telemetry platform, where we can then, and that's actually something very nice and for us super powerful, not only take the data that is coming from CPEs, but we can also correlate information from CPEs with other sources like local market, CRMs, or other sources which are feeding into the same analytics platform. yes, that's all I wanted to say about this. So then we started on something that was a bit more challenging and took us a bit more time. So software module management, we heard already a bit about this earlier today. What is the problem that we're trying to solve here? So with the ambition that we're having to transform the CPE into a service hub, we need some remote mechanism to be able to install a service, to update a service, to delete it, or to start and stop it. Yeah? So these are the normal lifecycle operations that you can run on an agent that runs on the CPE. And we can actually do this based on USP standard mechanism. Yeah? So there are constructs like an install DU command or a DU state change or set requested state. Yeah? So all of these are defined in the specification, and we are leveraging this to then be able to say to the USP agent, hey, here is a new version of a specific agent available. Go and download it. Or a customer has subscribed to a new service. Please download it and install it, and things like this. Yeah, so that's actually what we are doing with software module management. There were, during the implementation, I said it took a bit longer. There were 3 limiting factors that we've identified. So the first one was that we had problems, not sure if I should say that like this, but doing software module management over USP was, that's the impression we had when we asked our partners to implement it, was something that has never done anyone before. So obviously SMM is there, but it's normally done over TR69, and the integrations of the USP agent that we had in these proprietary firmwares did not support doing the same over USP. So we had to work very closely with our partner to make this happen and make this a reality. Now, meanwhile, it's actually working. We also faced the challenge that the way how the interaction with the CPE is defined comes with a high degree of asynchronicity. Yeah? So you need to imagine that almost none of the interactions that the controller has with the device is synchronous, which then requires a highly reliable and sophisticated state model that you need to be aware of and track in your backend. And that was a bit of a challenge for us. The second aspect, or better, let me give you an example first. Maybe then it's a bit clearer. Yeah? So if I remember correctly, the standard says the CPE has up to 24 hours to respond with a DU state change on an install DU command. That's what the standard says, if I'm not mistaken, or it at least said that at some point in time. Yeah, which then obviously for us requires that we needed the capability to somehow store the state of where we are in the provisioning and deployment process in our backend, and define a reliable process to continue the interactions with the CPE to actually complete the installation of an agent on the device. So this is software module management. Happy to take questions about that later. Parallel to SMM, we also started to work on a mobile application. So like I said, initially, the ambition is to bring down the technical barrier and to provide a nicely looking, good user experience to our customers. We do this by providing native mobile applications for Android, iOS, and Huawei devices. And the question that we asked ourselves when we started the work on this mobile application was, how can we securely make a communication between a mobile application over a public connection with the CPE that normally sits in the home? And this is how our solution looks like. So the user journey starts in the application with something that normally users are familiar with, but not a lot of broadband related applications are doing this, which is we are asking the user to log in. So we first of all need to identify who the user is. And we are doing this because our business wanted to have this a seamless experience, and they wanted to have the ability, which is also something that is different compared to how we did it in the past, wanted to allow the CPE management over the internet. And so the device should obviously be able to communicate with the device when it's logged into the local Wi-Fi, but the management of the CPE should also be possible from wherever the customer is. And so that was one of the challenging requirements that we took on board. And that for us then resulted into a solution where we first of all had to identify the identity of the user. With the knowledge about the customer, we only have half of the information that is required to initiate the pairing between these two entities, between the user and the physical device. So the information that was missing is how or who could now tell us to this user which CPE belongs to it. And we have implemented using another standard that's playing a big role in Vodafone, an HTTP RESTful interface that is according to the TMF API standard, which the local markets are helping us with. So they are locally integrating this API with whatever system they have available that keeps track of the link between a user identity and the physical device that is assigned to this user. So when the user logs in, we first identify the user. We then go with the user identity to this API. This API tells us this user belongs to this CPE, serial number XY or USP endpoint E, whatever we use. And we can then very directly create a link between these two entities. And the way how we are then actually doing the USP onboarding is that we've extended our Bootstrap controller with an API that the application can invoke, which then creates the provisioning process, which onboards the application controller onto the CPE. The CPE will then, like we discussed during the Bootstrap process, will make a request directly into the application and will say, hey, I'm the new USP agent. I've just been onboarded. Please configure me. Once that has happened, the pairing is actually completed and the application can start using the built-in MQTT mechanisms that we have in the application very efficiently communicate with the USP agent, can start retrieving information, can start changing stuff. Yeah? The nice thing for us is that Web GUIs are still quite important for us because some customers are actually using it. And the data model centricity of USP is actually helping us here, because what our application is in the end doing is nothing different than interacting with the 181 data model that is instantiated on the device, and it's the same data model that the Web GUI uses as well. So it's just a different interface, but hopefully a bit of a more user-friendly one. The next interesting application use case that I thought is hopefully interesting to share is a typical use case that our business wanted to have implemented, which is the question about how can we react to things that are happening in the home. A typical scenario is I want to notify a customer about a new device that connects to the Wi-Fi, and I want to notify the customer about this. There are two questions or two challenges that we faced. So the first one is obviously, how can we react to changes on the CPE? USP helps us here with USP subscriptions again. But how can we then also, when we take our architecture into consideration, transform and transmit this information back into the mobile application when we need to assume that the application does not 24/7 run in foreground and has an online connection with the MQTT broker. And this is what the solution looks like. So we've actually built a service that sits on top of our telemetry controller. What this allows us to do is that once the customer has provided consent and said, I want to receive notifications for events happening on my CPE, we are using an API that the telemetry controller exposes, which will then set different types of USP subscriptions on the device, so that whenever a change happens. That's similar to the telemetry process. Whenever a new device connects, if we stick to that scenario, when a new device connects, this creates an object creation in the host table. This is then transmitted into our USP telemetry backend. And from there, we are then transforming the information. And there's actually something that we've encountered, which was another challenge for us, because these events normally do not contain sufficient information to be able to turn this into something that you can send to a customer. Yeah? So, for example, object creation event normally give you the path that have been created, but doesn't tell you what's the MAC address, what's the name of the device and stuff like this. Yeah? So we had to build an extra process so that whenever the device makes the event and sends the event into the backend, that we're having a back and forth communication to collect the information that we need to then be able to send out the customer communication.
Just real quick, so I don't forget, you're saying it would be helpful to have the object creation notifications have a flag to include everything about that object when it comes on. Yeah. I know. Don't make that face.
It's definitely
so that you don't have to do a get.
Right? Yes, yeah. Definitely. That's something that I would like to propose, definitely, yes, because it saves us a bit of complexity, yeah. So something that gives us a bit of more context about the notifications so that we don't need to do this back and forth between the backend and the actual device. So the last part of the flow is then, once we have the event, once we have the information that we actually need, we can, via our mobile application backend, trigger a push message, which then arrives on the device and the customer gets the information that he needs. So the last use case that I brought is a more technical one, so not so much focused on the end customer, but it's something that came out more or less from the operations and the development people who are actually doing the implementation. So once we've reached the stage that we had stuff implemented and were testing it against real CPEs, we were from time to time struggling with getting access to log files that are on the CPE. So the resolution that we found for us is that there are nice mechanisms defined in the standard which allow us to identify which log files are available on the device. It's this vendor log mechanism. And we have an operation to instruct the USP agent to send the log file that's on the device to an HTTP endpoint. And we're actually using this. So we did put an API on top of the telemetry controller that we have, which then allows operations or someone from the development team to initiate a request. This then results into the upload command that is sent to the USP agent, and from there the information then goes into a cloud-based HTTP endpoint that then stores the file temporarily, and from there we can download it and integrate it into OSS tools that the different teams are using. So these were the use cases that I had, and just wanted to quickly draw an interim conclusion before I then talk about what we are working on next. So for us, USP is already reality. So this is the first device that we've released end of 22. This is a device that is available in Vodafone UK. So you can buy it in UK, and we are operating the backend since more or less a year. We are very happy. It's everything runs very stable. We are collecting information, and we are, as a company, fully bought into USP, because similar to what Volker is saying, it's bringing a lot of benefits, and it really allows us to deliver the strategy that the business wants us to deliver. We also got, that's what you can see here at the bottom. We got quite positive feedback from some independent journals about the device. So it's not only the backend platform, but also the device. And that's something that we're obviously quite proud of, and shows that we are on the right track. And what this means is that like I already said, Vodafone as a company is fully bought into USP, and we are at the minute in a phase where we are really trying to expand and scale the platform. So this has for us two dimensions. The one dimension is that we are working on releasing new devices to new markets. So like I said, currently it's still quite a small deployment in the UK, but we are working on bringing this to other markets as well, including new devices that are equipped. And as per the strategy, all new devices that we'll be releasing will have a USP agent integrated in them. We are also working on trying to bring a USP agent into some high volume legacy devices to make these legacy devices benefiting from these additional features and these capabilities, these different use cases and scenarios that I talked through. Like I said, we are working on RDK that we are eventually and ultimately having end-to-end software control over the entire platform, starting from the CPE, reaching then into our backend. So that's the next big milestone for us, which we haven't reached yet, but we are on good track, I would say. There are still two things which are impacting the speed that we would like to have, or that is impacting the pace that allows us to release new stuff. One is that there is still a dependency, even if you have an agent fully containerized, but a lot of agents come with dependencies to the data model, and that's something that currently only works when you are changing the firmware and you integrate these new data models into the firmware. USP 1.3, we heard about that yesterday, and John did an excellent presentation about the new features in USP 1.3 with the UDS, MTP, and the ability for service agents to register their own data model. And so this is bringing us to the next level where we are then actually able to reach more independence from the firmware. And the other aspect that I wanted to mention is dynamic controller trust. So this is also something which currently is a bit tricky for us, because at the minute during firmware compilation time, we need to define what roles the different USP controllers have and which permission they have on the data model. And that's something we would like to have more dynamic, so that whenever there's a new feature in the app, for example, which requires a new data model parameter to be read, that we can dynamically provision this, which is currently not possible. And then the last point that I wanted to mention is that there's nowadays, there's no tech presentation without the AI buzzword on them, and I make no exception here. So with the additional information that we are now collecting and that we are feeding into our telemetry backend, we've started with the first experiment to train a machine learning AI model based on this. And the ambition, the hope that we're having is that we will reach a state that we have somehow a mechanism and a model that is able to, for example, detect difficult for a German to pronounce, you know what I want to say? Thank you, Jay. Anomalies, yes, which then actually help us to take preventive actions before they're actually distracting and disturbing customers. So that's something that we are currently experimenting with, and we have high hopes in. So that's all that I had to prepare in terms of content. I hope I stick within the time. Happy to take questions.
No, that's great. So this is awesome. I literally turn every one of those use cases into a white paper.
Thank you. My name is Gregory from Itopera. I have a question about Web UI. You have considered to move all communication between Web UI and gateway over USP, because as I see here, you have different protocol for that, or different way to communicate.
Yeah, but Web GUI is actually something that is still served by the CPE, so it's software component that runs on the CPE, and the connecting element for the actual data that is presented is the data model that runs in the CPE.
Okay, I understand.
Yeah.
Thank you.
So I have also a question. You mentioned this is in production in a small setup in the UK. How small is small?
Well, like I said, it's the first device that we have live. It went live end of 22.
Right.
Our commercial department said I shouldn't share any numbers, but I'm definitely admitting that so far it's still a small deployment and that we are in the phase of scaling this currently. So we are not in the multi-million devices range yet.
4-digit, 5-digit, 6-digit.
Let me better not comment on this. It's a small deployment. Yeah.
Okay.
But
And
like I said, I mean, the ambition is also we are fully bought into it. We are happy with it. We haven't had any big problems in this 1 year that we are operating this now. So, and we are now in the phase that we are really scaling it up.
a lot of things are relatively easy if you are in small numbers. So
Yes,
that's why I'm asking, you know.
I'm definitely admitting to this. Yeah. So far we are making very positive experience, and we are happy with that. And obviously, when you are scaling a platform, new problems come that you then need to address.
Yeah. Well,
I might come back if you let me.
they mentioned numbers last event, but it wasn't quite clear, you know, where these numbers came from. So, question number 2. What was question number 2? Oh no. I wanted to know which of the use cases are actually implemented in that particular setup. So you mentioned, you know, lifecycle management, telemetry data.
So we have the telemetry controller live since day 0 that we released the device. So we are collecting information in that deployment since more than a year now. The app went live a couple of months ago, fully in production. We had a POC that went live a couple months earlier. So let's say the app is now live since roughly half a year, I would say. The SMM use case is not working in production yet, but we are close to releasing it to production. So we have it working. We have tested it on different platforms. On this one device that we have in the field, we have another RDK-based deployment where we've tested and seen it working, but we haven't used it in production yet.
Okay, thank you.
Where does the LCM component?
Real quick before you start. Given no, I'm not saying we have to leave right this second, but given that people are probably starving, would it be interesting? I just had Craig run out to smash a couple tables together at lunch, so that's more than just 8 seats if people want to keep talking about this stuff. Go ahead.
Where does the LCM component come from?
Well, that's one of the challenges that we see. So we have one partner that we started this journey with, which is an OpenWRT-based system, which uses the let me say the proprietary mechanism that comes with the platform of the partner. And like I said, we've started also to do SMM on RDK-based devices where we're obviously using some of the stuff that from the Purple Foundation is trying to be fed back into RDKB.
Right.
But that was actually, like I said, one of the initial problems that we have, that we had all the constructs from a backend perspective that we could theoretically do a deployment on a device, but the actual lifecycle integration into the device wasn't ready yet, and we had to wait for our partner to make that happen.
Björn from Dumos, wanted to briefly bring up that point that you had about having to define access to the data model and stuff like that at the compile time, basically.
Yeah.
What's missing to remove that limitation? And yeah, might be a question for you or for more people in the room, actually. Yeah.
So from pure standards perspective, I would say everything is there, everything's ready. So you can start manipulating the RBAC roles that are associated.
I'll go home.
The problem for us was, again, specific on the device, that the dynamic change of manipulations that you make on these RBAC roles were not automatically applied by the platform, and that drove us into a situation where we simply had to upfront define what are the roles that our different controllers require, what are the permissions, and we all know how the standard looks like. We need to define this really on a parameter basis, so that's a bit of a tedious thing, and obviously hindering us in releasing and changing things with a higher pace and more frequency.
Thank you.
All right. Any other quick questions before we break? Awesome. This is awesome. Thank you, Marcel.
Cool. Thank you very much for having me.